Dear friends, in this video, let us go ahead and understand how to balance the chemical equations. By the way, what are balancing chemical equations? It's very simple. Balancing is nothing but meeting the supply and the demand, right? Let's say if you are demanding for more, there should be some person to supply that much. Let's say if there's a demand of 5 kg of rice, right, from a family, then the supply should be 5 kg of rice, right? There should be somebody who will be supplying. Or let's just say on the other way around, there is a person who is ready to supply 10 kg of rice, but then there has to be a balance in the demand also. It means the consumption has to be equal to 10 kgs, right? Because a person is ready, they are supplying 10 kgs of rice, it means there should be one or the other person. How many people are there? That is not a botheration. How many families are there? Not a botheration, but the what is being supplied has to be distributed among equally or has to be consumed. That's all is what I'm looking out for. Here, my intention of this video is very simple. It is to make you to understand how to do balancing in a very easy and a simpler methods, right? Rather than just taking them as this atom, this chemical, that chemical, what we do is we'll go a little beyond. Instead of taking this as chemical names, let us push ourselves something like of the food packets, right? In Corona time, the government used to supply the packets. When they used to supply food packets for a family, in a food packet, it contains what food items are the groceries which are needed for the family for a month, like that, right? What are those usually food items? The groceries that will be something with rice, dal, tamarind, salt, oil, and then chilies and atta and whatnot. Whatever has been is there, whatever is the requirement, everything will be packed inside and it will be given, right? So here we have a small test. That being government, irrespective of number of people, irrespective of how many members are there in the family, they used to supply equally. Here, what we people for balancing the chemical equations, what we do is we become a little more intelligent. We see, okay, if the demand is for 2 people, then the supply is less. If the demand is for 10 people in a family, the supply is more. And some people, they are more of rice eaters. So the supply of rice is more for such families. Some people, they are more of wheat, atta eaters. So for that, atta the demand is more, so let's supply more of that and reduce the rice, like that. So we are going to balance based on the need and necessity, right? So what the supply we've got from the government, we will keep that in a godown, right? When they are supplying, let's say tur dal, let's say rice, let's say oil, they supply it in big um, packages. Rice comes in big sacks, chila, godi chila, 50 kgs ಆ ತರ ಆಟ ಆಲ್ಸೋ ಕಮ್ಸ್ ಲೈಕ್ ದಟ್. ನಾವೇನ್ ಮಾಡೋಣ, ಅದನ್ನ ತಗೊಂಡು ಒಂದೊಂದು ಕೆಜಿ 2 kgs ಅಂತ ಹೇಳ್ಬಿಟ್ಟು ಪ್ಯಾಕ್ ಮಾಡೋಣ. ಸೊ ಯಾವ ಮನೆಗೆ 2 kgs ಬೇಕು ತಗೋ, ಆ ಮನೆಗೆ ಇದು. ಯಾವ ಮನೆಗೆ ಸಾಲ್ಟ್ ಅಂಡ್ ಆಟ ಅಷ್ಟೇ ಸಾಕು, ಆ ಮನೆಗೆ ಇಷ್ಟೇ ಕೊಡೋಣ. ಯಾರು ಹೇಳಿರ್ತಾರೆ ನನಗೆ 2 kg ಸಾಲ್ಟ್ ಬೇಕು, ಓಕೆ, ಆ ಮನೆಗೆ 2 kg ಸಾಲ್ಟ್, 5 kgs ಆಟ ಬೇಕು ಅಂದ್ರೆ 5 kgs ಆಟ, ಈ ತರ ಮಾಡೋಣ. ಬಟ್ ದೆನ್ ಗವರ್ಮೆಂಟ್ ಇಂದ ಬರ್ಬೇಕಾದ್ರೆ ಹೋಲ್ಸಮ್ ವಿ ವುಡ್ ಆಫ್ ಗಾಟ್. So this is just a simple thing that we need to visualize before we get onto the chemical equations. Now let us understand. When it is chemical equation, it is not atta, it is not salt, it is not rice, it is not tamarind. It is the chemicals which are there in the periodic table that you are mostly used for. Okay, or maybe your first 20 items or something like that, whatever the chemical names. So whatever is the number of items supplied, the number of chemicals supplied, they have to get balanced equally, or based on the demand we need to increase the supply. Okay, so imagine you being the agent to take from the government and supply it to the families in your colony. Can you please go ahead and imagine deeply, you are holding a bigger position now where you are going for such kind of work, where based on the family requirements, you are taking the family requirement for the first thing, and then based on that you are going for the supply of it, right? Okay, so fine. Now in this list I have many unbalanced chemical equations. Okay, here goes my list, and let me just bring down my screen. Okay, So here I have lot of unbalanced chemical equations. So what I'm going to do is I'm going to show you the method how to balance them. Right. So before even balancing chemical equations, I here one thing to notice, I'm mainly on decomposition equations, not on the combination equations. Got me? So let us go for it. So here we have a new list where we are going for the decomposition reaction. As I just earlier, decomposition is very easy for understanding than combinations, right? Okay, CaCO3, it is getting decomposed to CaO and CO2. So fine. Now let us go for the supply and the demand. This is a supply and this is a demand. So there is one family which is requiring for 1 kg of calcium. Let's understand in this way. 1 kg of calcium, but what is my supply? It's also 1 kg. So supply equal to 1 kg and the demand equal to 1 kg. So the condition is met and it's balanced. Now carbon. So there's 1 kg of carbon which has got supplied and the demand is also 1 kg is done. But then here oxygen, when it's getting supplied in a bag, it is 3 kgs of oxygen which is getting supplied at a time, right? So now you need to imagine that there's a big bag, a big chela in which 1 kg calcium is there, 1 kg carbon is there and 3 kgs of oxygen is there. So here what happens is, there are how many families are there? One family and two family. One family requires 1 kg of calcium and 1 kg of oxygen. That is done. And another family requires only 1 kg of carbon and 2 kgs of oxygen. So here oxygen was 3 kgs. So that is split into 1 kg and 2 kg. Fine. And it was given to one family. And here oxygen was 2 kgs and that's been given to another family. So fine. Here we don't have any issues because it's already balanced. Let me go for third one now. HGO getting split to Hg and O2. HGO getting split to Hg plus O2. Right? Here comes the balancing part. Look, from the government, the supply is in a bag. ಇನ್ನೊಂದು ಚೀಲ ಗೋಣಿ ಚೀಲ ಸಪ್ಲೈ ಎಷ್ಟಿದೆ 1 kg HG 1 kg ಆಕ್ಸಿಜನ್ ಎರಡನ್ನು ಒಟ್ಟಿಗೆ ಸೆಪರೇಟ್ ಆಗಿ ಪ್ಯಾಕ್ ಮಾಡಿ ಹಾಕ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಬಟ್ ಒಂದು ಫ್ಯಾಮಿಲಿ ಡಿಮ್ಯಾಂಡ್ ಎಷ್ಟಿದೆ? there are two families. How many families? Two families. One family requires only HG. Fine. Supply is also 1 kg. That is done. Another family requires 2 kgs of oxygen where my supply is only 1 kg. So on my left hand side, I am still in deficit of 1 kg, right? So now what should I do? See, there is one full bag which came. Now if I want only 1 kg extra oxygen, I can't get them because the government every time it supplies in that big chela which contains both Hg and O. So what happens is, now instead of one chela, the government supplies me 2 chelas. So it becomes 2 HGO. Thereby my oxygen in this 2 chelas, right? ಈ ಎರಡು ಗೋಣಿಯಲ್ಲಿ ಒಂದರಲ್ಲಿ 1 kg ಆಕ್ಸಿಜನ್ ಇದೆ, ಇನ್ನೊಂದರಲ್ಲಿ 1 kg ಆಕ್ಸಿಜನ್ ಇದೆ. ಈ ಎರಡು ಕೆಜಿಗಳನ್ನ ತಗೊಳ್ಳೋಣ. ಇದ್ರಲ್ಲಿ 1 kg, ಇದ್ರಲ್ಲಿ 1 kg. ಸೊ ಒಂದ್ ಫ್ಯಾಮಿಲಿಗೆ ಬೇಕಾಗಿರೋದು ಓನ್ಲಿ ಆಕ್ಸಿಜನ್ ಕೊಟ್ಟು ಬಿಡೋಣ. ಡನ್. ಇನ್ನೊಂದು ಫ್ಯಾಮಿಲಿಗೆ ಬೇಕಾಗಿರೋದು ಬರೀ HG. ಅವ್ರೇನು ಕೇಳಲಿಲ್ಲ, ನನಗೆ ಒಂದು ಬೇಕು ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಇಫ್ ಯು ಗಿವ್ 2, no problem, because we just need to balance and we'll say that keep it for next month, no problem. That is done, right? So this is how we are going to balance the chemical equation, for which we are just going for the visualization. Rather than speaking on the chemical part, we are going for the visualization. Now let us go for the third one, which is KClO3 getting decomposed to KClO4 and KCl. Okay, I hope you guys have written down this. I want you guys to please write down this and balance them with your own mind. You just don't need to copy it and again come with a blank mind. These videos are not meant just for copying sake. Okay, so now what I'll do is, I will erase the first two equations what we worked upon, right? Next, we will take the first equation, what I said there. Why did I take the first equation in the beginning? Because I felt it is maybe a little tough for you guys to understand. So that's why I thought, let me go for the third one and make you to second one and third one and then make you to understand. All right, now I'll go for writing it like KClO3 giving rise to KClO4 plus KCl. All right. So as I said, now the government has changed the rule or based on the colony. It said, look, I'm supplying you a big bag, right, which contains KCl and O3. Now go and do your work. This is a family. Now this family wanted KClO4. One family, it's a need of K, 1 kg of K, 1 kg of chlorine, 4 kgs of oxygen. The other family requires 1 kg of K, potassium and 1. This is what the family wants. Now what shall we do? So the first family said, I want 1 kg of potassium. Fine, I'm giving it. But even the second family wants 1 kg of potassium. Now my supply has to go for 2 kgs of potassium. Am I correct? Yes. Now the other family wants, one family wants Cl 1 kg, even the other family wants Cl 1 kg. So if I increase my supply to 2 kgs of this bag, this chela, which contains 1 kg K, 1 kg Cl and 3 kgs of oxygen, my supply is met for both the families with respect to potassium and calcium, right? Okay, that is done. Next we go for this oxygen. This is a point where we need to have a closer list. Okay. Now, supply is 3 kg. There's a big bag which has 3 packets of oxygen. Demand is 4 kg. So, demand has exceeded the supply. Now, supply has to increase. But will it give me only oxygen separately? This time it is not. What I should do? I have to take another bag. And already we know taking 2 KClO3 will balance potassium and calcium in for both the families. But then of course oxygen also come together because they are coming in the bundle. So it means 3 kgs of oxygen in one bag and 3 kgs of oxygen in another, which becomes 6. But my demand is only 4 kgs. 2 becomes excess. I will not waste it. Now what should I do? Okay, now what should I do? I will go ahead and increase the supply so that nothing gets wasted and the families will get the balanced need of the food packets. Now instead of 2, if I make 3 KClO3, 3 K of 3 kgs of K, of course that's not possible because both the families wants 1 kg. This is not possible. Now I go for 4 KClO3. So here it is 4K, which will get split to 2K and 2K. Fine. 4Cl, 2Cl and 2Cl. That's also correct. 4O3, which becomes 12O, right? So I am supplying 12 atoms of oxygen at a time. Now, only one family wants oxygen, which is O4. In one bag, there should be O4. So, because I am supplying 4 3 yes, because I am supplying 3 kgs here. How it becomes 3 kgs? 3 KClO4 plus 3 KCl. Look, here it is 3 kgs of potassium plus 3 kgs of potassium here. Sorry, 1 kg of potassium. 1 kg of potassium, which becomes 4 and this gets balanced. Next, 3 Cl, right? So, which will be like, the supply is 4 KCl, but the demand is 3K in for 3 Cl for one family and 1 Cl for another family, which got balanced. And then the another demand is oxygen, which is one family requires 4 kgs. Because I can't supply, what I've done is I've given them 3 packets so that they'll get everything. So here It becomes 12 kgs and that's the demand, and what I am supplying is also 12 kgs. Why did I go for this? Is not there a different way of doing it? Yes, there is there can be different method, but we are trying to visualize, and more on that here we get to know the difference in the demand and the supply, and there will be another technique added, something called the multiples. Okay, so now what I do is, let me erase the board from here. Okay, so here we said supply of oxygen was 3 in one bag. Next, if I give 2 bags, 6. If I give 3 bags, it becomes 9. But the demand at the time was 4 in one bag, 8 in another bag, 9, 12 if I give 3 bags to that family. So as you move on, you see this is in the multiples of 4 and this is in the multiples of 3. Okay. So where can the supply and demand meet when the multiples of 4 and 3 comes into a common conclusion, that is 12. So what did I do here is, look, it was initially 3. When I supplied 4 packets, the oxygen became 12. And when I supplied, yes, here the requirement for per family in the demand side or on the RH side, it was 4 at time. So I supplied 3 bags. So 12, done. Okay. So accordingly, I started balancing the other chemicals also, so that there is no wastage. What I supplied, what was the demand, both are met. So my equation is balanced. All right. So now let me do one thing. I request you guys to please take this down and practice it at home. Maybe initially you may feel like this is more of a story kind of thing, and is it so much required? It's not so much required, only for the beginners this is required. Later on, you get to know how you can do it on your own and very easily, but provided you follow the technique here. One, what we discussed is on the visualization. The next thing is on the multiples, right? So the multiples of oxygen has to get balanced with the multiples of oxygen on the right hand side. Both left and right got balanced. All right. So now I'll do one thing. I'll take you all to the next equations which are there in the series. Okay. I'm just dropping the board, the whiteboard. If anything else is left out, what I do, I'll just scratch them. Okay. So what are there in my basket? Okay. Now, can you just go for PBNO NO3, which is, yeah, PBNO3 twice. And there are 3 families who wants this demand now. I'm just copying this from here, and so that I can paste easily, and my time and your time is saved. Okay, so now we go for this PB NO3 two items, PBO plus NO2 plus O2. We are discussing on this now. So if you look, the supply for this area is so much, NO3. It means what are the PB, 1 kg of PB, NO3, it is one packet in which N and O3 are there. That is how many kgs? 2 kgs. So for one packet, ಒಂದು ಚೀಲದಲ್ಲಿ 1 kg PB ಇರುತ್ತೆ, lead ಇರುತ್ತೆ, 2 kg ನೈಟ್ರೋಜನ್ ಆಕ್ಸೈಡ್ ಇರುತ್ತೆ. ಇನ್ನೊಂದು ಸಪೋಸ್ ಈಗ ನನಗೆ ಒಂದು ಪ್ಯಾಕೆಟ್ ಸಾಕಾಗಲ್ಲ, ಒಂದು ಚೀಲ ಸಾಕಾಗಲ್ಲ, ಇನ್ನೊಂದು ಚೀಲ ಕಳಿಸ್ತೀನಿ ಅಂದ್ರೆ PB becomes 2 and here NO3 becomes 4. The same thing for 3 packets, 3 sacks. So this becomes multiples of 1 and NO3 becomes multiples of 2. How do I get it easily without all this big story? It is just written here. NO3 of 2 means it is multiples of 2. So if you look for the second equation, PtCl4 giving to Pg and 2Cl2. Look, at the supply side, it is 4. So, when in one bag, there are 4Cl, 4 chlorine, right? It means every time when I am supplying, it will be in terms of 4, 4, 4, 4, 8, 12, 16 and so on. Look at the demand. It is Cl2 at one time. In one bag, Cl2. In another bag, if I supply the same thing, once more, it becomes Cl4. So, it is multiples of 2. So, you get to know whether they are multiples of 2 or 4 or 3 by the numbers which are denoted, which are suffixed down. Alright. Next. Okay, fine. So, this is on the supply side. Now, let's work on the demand side. On the demand side, how many families are there? This PbNO2 is getting split 2, NO3 of 2 getting split 2. One family wants what? Only PbO, lead oxide. Another family wants nitrogen oxide. Another family wants only oxygen, 2 kgs. One second. Yeah. And another family is there which wants only oxygen. So, is it right? Okay. PbO, NO2 and O2. Okay. See, balancing chemical equations is just a pure number game. Here, if I give one, I have to balance with other. If I take one from here, I have to balance with the rest left out. That's all is what we need to do. All right. Okay, come. Let's solve this. PbNO3 of 2. Okay. How many PBs are there? 1 kg. And here, there's regarding only one family wants PB. So, 1 kg I am supplying, 1 kg is demanded, done. So, I don't need to work on that. Next, this NO3 of 2 is, let us work on this further. It means every time when I am supplying 2 atoms of N and 6 atoms of oxygen. My supply is like this. But here look, here there's one family, the second family who wants only 1 kg of nitrogen. But my supply is 2 kgs at a time. In the sense to say, in one pack it is 2 kgs. Now what should I do? I have to, let us say I am supplying 2 packets, 2 sacks. ಎರಡು ಚೀಲ ನಾವು ಏನಾದರೂ ಅನ್ಕೋಬಹುದು. For now, for the second family, I am supplying 2 kgs. So, if I supply 2n, 2n, oh fine, this has got balanced. Now, when I say 2 packets, now oxygen becomes 4. In one it is 2, in the other one it is 2, it became 4 now. Okay, if there is 4, oxygen supply was 6 and 4, the other family, the third family wants only 2 oxygen. So, 4 and 2 I have to give to the third family which became 6. 6 kgs are confirmed. So, it means the supply was also 6. Look here, and the demand is also 6. That is met. Done. Now, how will I balance this, or how will I write this balanced chemical equation? What I do is I'll just go here. All the change we required was that we had to the second family, we had to submit 2NO2. So, if that's the case, I just do like this. If that is the case, I will take it like PbNO3 of 2 giving me PbO plus 2NO2 plus O2. That's all is required. The underlined one, the one which is marked, is your balanced chemical equation. Don't get confused. Alright. This is the balanced chemical equation. All we did is, instead of supplying 1 kg, 1 bag of NO2, we supplied 2 bags and we could balance it. Okay. So, I said the left side and the right side has to be matched. Okay. Now, let me erase the board and take you for the next one. Should I need to do the fourth one? No, I will leave it for you guys. You do the fourth one or whatever, the fifth one which is there in the list. Let me go for, okay. I will show the simple equations which are here. I'll go for the copper oxide. The first one, CuO plus C. Look, here Cu got liberated out and C and O got combined to CO. So the demand is met and the supply is equal. Supply and demand are equal. Next, we go for CuO plus H2, which becomes Cu got liberated and H2 plus O got combined to H2O. That is done. Next, so here comes few of our equations which are unbalanced. Let's go and balance them. I will pick few of them and rest of the things I will leave it to you. You need to go ahead and balance the ones. Right. So what I'm going to do is I will go for the second one. Let me take the second one initially for you so that it is easy. It's sodium plus water giving rise to sodium hydroxide plus H2. Okay. It is sodium Na, one second, Na plus H2O giving rise to NaOH, sodium hydroxide plus H2. Okay, let's observe the supply 1 kg of Na. Supply demand 1 kg of sodium Na. Done. Okay. Oxygen 1 kg and 1 kg done. And here comes the matter of hydrogen, which is one family wants 1 kg, the other family wants 3 kg. So at a time, what is my supply in terms of hydrogen? It is 2 at a time, 4 in the second bag and 6 in the second bag and so on. Here if I come, there is a requirement of 3 kgs at a time if I am just looking at the balanced equation. So now your question will be, every time when I am giving one bag extra to one family, do I give extra to another family also? For example, if I say 2 NaOH to one family, should I give it like 2 H2O? Need not be. Alright. If that's the case, you can't balance. Sometimes it can so happen that one family, let's say the sodium hydroxide, can say, okay, this is enough. That one bag, what you have given me, that's enough. You just balance the other family. So at that time, what do we do? Here, you observe that the H2 is in the multiples of 2, 4, 6. I mean, it's in the multiples of 2 and hydrogen has to be balanced. Now, what should you do? Here, as you know, it is an unbalanced equation. So, next time if I am supplying, I will take 4. Will I be able to give 4 for the hydrogen items? If at all I am giving to where will I go? Give. Okay, fine. Forget about that. I said I am supplying to H2O. Alright. Okay. Let me just do this here so that it is easy for you just to see. All I said is I am supplying, 2 H2O. Instead of one bag of H2O, I am supplying 2 bags of H2O. That time hydrogen became 4 and oxygen is 2. When oxygen is 2, it's my duty to supply another bag of NaOH so that my oxygen becomes 4. Oxygen, what I am supplying will get balanced with my demand. Now, if that's the case, my sodium has to supply has to be 2 bags. Correct? Okay. Then if that is the case, okay, the sodium got balanced and then oxygen got balanced. Again, something we need to work upon is with hydrogen. Now, this family consumes 2 hydrogen pockets and this family consumes another 2 hydrogen packets which become 4 hydrogen packets. What I supplied is 4H and what my demand is 2H plus 2H which becomes 4H and this equation becomes balanced. Got it? So it's all about what is the one that we select for balancing. Now, let's rephrase this. Why didn't we touch sodium at the first time? Because, look, sodium is one packet we are supplying and it is also consumed by family which is only one packet. So, there's no need to touch it. Next, oxygen again is the same thing. So, we are not touching. Hydrogen is where we need to work upon. Where there is a variation in demand and supply, work on such of them. Alright. Okay. And mostly the metals gets balanced, not in every time. So, we'll see. Right. Alright. Okay. So, having said this, please take down the notes. I will go for the further ones. Okay, you want me to write the balanced equation again here? Yes. 2H2O, 2Na plus 2H2O giving rise to 2NaOH plus H2. That's all is the balanced equation. Okay, fine. Let me erase the board now. Okay, so now I'll move on. N2 plus 3H2, N2 plus H2 gives me NH3. NH3. My duty is what? Balancing. Probably there in the other sheet I would have shown unbalanced equation. I guess, yeah, it's got balanced, but don't worry. Your duty is to balance them, and I'm showing that. Now, what the government is doing? It is supplying two sacks. ಎರಡು ಚೀಲ separate ಮಾಡಿದೆ. Okay, this is one ಚೀಲ, ಗೋಣಿ. This is another goni. Here has N and N, 2 kg. And here it has H and H, 2 kg. So, this is one goni. Next time, suppose if it wants to supply, it will give another goni, chila. So, it becomes every time multiples of 2, 4, 6. Here again, multiples of 2, 4, 6. Okay. Here, there's only one family which is consuming. So, this family wants 1 kg of NH. Next time, if I'm supplying a big bag, another bag of NH3 inside that, it's 2. 3 multiples of 1. H is in the multiple of 3, 6, 9, 12. If I'm supplying 4 bags of NH3, it becomes 12 of hydrogen, which is if I'm supplying 4 bags, 1 bag, second bag, third bag, fourth bag. In each of the bags, there were 3 hydrogens or 3 kgs of hydrogen also you can take. Okay, fine. If that's the case, so it is just, now when I said this kg, sacks and all, it's only for our visualization purpose. Okay, so now let us write down. You said it is N2. I'm supplying 2 kgs at a time. So it means this has to be 2. NH3 has to be 2. Okay. If that's the case, will I be able to balance? But I'm supplying 2 hydrogens. But when I say 2 bags of NH3, it means a hydrogen becomes 6 kgs. But here my supply is only 2 kgs. Okay. So here every time it is coming with the multiples of 2, 4, 6, 8. Here it is coming with the multiples of 3, 6. Okay. It means one bag has 2 hydrogens, second bag has 4 hydrogens, and the third bag, if I give it has 6 hydrogens, give 3 bags. So your equation gets balanced. N2. In one bag, I am supplying 2 kgs. Here, of course, in in one family, they wanted only 1 kg in one bag. And let me give 2 bags. What is wrong? So that they'll not come next time and ask me. Done. Next, hydrogen at a time. In one bag, I am supplying 2 kgs. Right? So, if I am giving 2 kgs to balance sodium, I am giving 6 kgs. So, thereby my supply has to be 3 bags. In each bag, 2 plus in another bag 2, in another bag 2. So, in 3 bags, it is 6 kgs. We are done. Okay, fine. Write down this balanced chemical equation. Let me take you for some more. Okay, fine then. So, here I will take you down for, I did the second one. Let me go for CH4 plus OH, O2, the sixth one. Okay. Okay. Now what we do here again, we are thinking the same thing. Okay. This is how the government is supplying. 1 bag of C, 4 bags of H at a time. Here, 2 bags of O at a time. This is okay. And there are 2 families which wants. One family wants 1 bag of carbon, C, 1 bag. The second, and then oxygen, 2 bags. So here, there's another family which wants H, 2 bags, 2 kgs in 1 bag, H 2 kgs, oxygen 1 kg. You got me? So CO2, if I say, C is 1 kg, oxygen is 2 kgs, and here H2O, if I say, H is 2 kgs and oxygen is 1 kg. Okay, if that's the case, let me go ahead and balance. Let's look for the stable ones. 4, C is 1. Here also consumption is 1. So I am not touching on C. Got it? Because supply and demand are met. Next, hydrogen 4 kgs is a supply. But then here 2 kgs. And every time when hydrogen is getting supplied, it is in multiples of 4, 8, 12. With one chila, it is 4. With another chila, it becomes 8. With one more chila, it becomes 12. But the demand is only for the second family with H2. So, when I am supplying one packet with 4 hydrogens, 4 kgs of hydrogen, here it is taking 2. And so, now what I do? 2 H2O if I do, it means hydrogen gets balanced. Now, how about oxygen? It is looking for 2O. Okay. How about this? Yes, it's got balanced. Right. Okay. Now, then carbon 1 and carbon consumption is also 1. H4, it is in the multiples of 4, 8, 12. And here it is in the multiples of 2 and 2, 2. So, therefore, it is 2, 4, 8. So, if I pick this as my demand and this as my, so this and this as the demand and the supply, they both are met. Done. So, is there a change anywhere? All the change I require is supplying 4 H4 and the demand has to be 2 bags of H2. That's all. So, thereby my balanced chemical equation goes like this. CH4 plus O2. There's no change in the supply, only in the demand side. All I'm doing is I'm adding 2 more bags. Done. Okay, please copy this and let's move on. It's just not copying. Copying doesn't make any sense. It is that you're understanding. Please understand the way that I'm explaining, and later on as we go further, we don't require so much of explanation. We can just move on very quickly, right? Okay, fine. Having said this, it's my duty now to erase this and move for C6H12O6, which is glucose, giving me carbon and hydrogen. Okay, yes, supply from the government has like this 6 kgs of carbon, 12 kgs of hydrogen, and 6 kgs of oxygen. But it is required by C6H12O6. It's been required by how many families? One family. It says I want only carbon, and that is in the multiples of 1, 2, 3, because every time it is required for only one carbon. And second family is getting split, they want only H2O, that is water, and in that H is in the multiples of 2, H is in the multiples of 2, 4, 6, and O is in the multiples of 1, 2. Now let's balance. How many are the carbon supply? 6. And one family wants 1 kg in one packet. So let's supply 6 kgs. If I supply 6 kgs, then this got balanced. Now let's go for H12 and O6. Okay. How many kgs of hydrogen I am supplying? 12 kgs. How many is in the need? 1 bag, 2 kgs, 4, 2 bags, 3 bags, 6 kgs, and then 4 bags, 8, 5 bags, 10, and 6 bags, 12. 6 bags has 12 kgs. Okay, this is my thing. Now, O6 and H2O is what I said. So, for the second family, I want every time it is in that big bag, it wants 1 kg of oxygen. So, when I am supplying 6 packets, 6 ಚೀಲ ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದರೆ 6 kg ಆಕ್ಸಿಜನ್ ನನ್ನ ಸಪ್ಲೈ ಎಷ್ಟಿದೆ 6 kg, ಡಿಮ್ಯಾಂಡ್ ಎಷ್ಟಿದೆ 6 kg ಡನ್. ಸೊ ಇಲ್ಲಿ ಹೈಡ್ರೋಜನ್ ಗವರ್ಮೆಂಟ್ ಸಪ್ಲೈ ಮಾಡಿದಾಗ 12 kgs ಇತ್ತು. ಡಿಮ್ಯಾಂಡ್ ಎಷ್ಟಿದೆ ಒಂದು ಬ್ಯಾಗ್ ಒಳಗೆ ಒಂದು ಚೀಲದೊಳಗೆ 2 kg. ಸೊ ಒಂದು ಚೀಲದೊಳಗೆ 2 kg ನಾನು ಒಟ್ಟಿಗೆ 12 kg ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ಅಂದ್ರೆ 6 ಬ್ಯಾಗ್ ಮಾಡಿ ತಗೊಂಡ್ರೆ 12 kg ಬಂತು. ಕರೆಕ್ಟ್? ಥಿಂಕ್ ಇನ್ ಯೋರ್ ಓನ್ ಟರ್ಮ್ಸ್. ನೆಕ್ಸ್ಟ್ ಕಾರ್ಬನ್. ಕಾರ್ಬನ್ ಒಂದ್ ಸಲಕ್ಕೆ ಆ ಬ್ಯಾಗ್ ಒಳಗೆ ಗವರ್ಮೆಂಟ್ ಏನ್ ಸಪ್ಲೈ ಮಾಡ್ತಾ ಇದೆ ಗವರ್ಮೆಂಟ್ ಅಂತ ಸೀಲ್ ಹಾಕಿದ್ದಾರೆ ಅಂದರೆ ಅದರಲ್ಲಿ 6 kg ಇದೆ. ಇಲ್ಲಿ ನಾನು ಪ್ರತಿ ಸಲ ಒಂದು ಫ್ಯಾಮಿಲಿ ತೀರಾ ಸಣ್ಣ ಫ್ಯಾಮಿಲಿ ದೇ ವಾಂಟ್ ಓನ್ಲಿ 1 kg ಆಫ್ ಕಾರ್ಬನ್. ಸೊ ಹಾಗಾಗಿ 6 ಬ್ಯಾಗ್ ನ ಕೊಟ್ಬಿಡ್ತೀನಿ. ಸರಿ, ಹಾಗಿದ್ಮೇಲೆ ಮೈ C6H12O6 one family wants 6 packets, 6 chelas of carbon. The other family wants 6 chelas of H2O, water. So my equation got balanced, right? Okay. Let me move ahead. That is, I know, I'm sure by now you would have understood. So I think I can go a little faster now, taking such simple equations only. The rest of the things, probably, I think I can leave it to you guys for balance. Okay, so here let's go. Again, the same thing. In this one bag, what the government is doing, 3 kgs of magnesium and 2 kgs of nitrogen. Okay, so it means if in one big ಚೀಲ ಒಂದು ಗೋಣಿಯಲ್ಲಿ 2 kg ನೈಟ್ರೋಜನ್, ಎರಡನೇ ಗೋಣಿ ಕೊಟ್ಟರೆ ಏನ್ ಮಾಡ್ತಾರೆ, 4 kg ಆಗುತ್ತೆ, ಮೂರನೇ ಗೋಣಿಯಲ್ಲಿ 6 kg. So nitrogen is going in the multiples of 2, magnesium going in the multiples of 3, correct? So this came to be Mg3N2, right? Next, H2O in ಒಂದು ಚೀಲ ಸಪ್ಲೈ ಮಾಡುತ್ತೆ, ಅದರಲ್ಲಿ 2 kgs of hydrogen and 1 kg of or 1 atom of oxygen also you can take. So hydrogen is coming in the multiples of 2, 4, 6. Oxygen is coming in the multiples of 1, 2. Okay, this is on the supply side from the government. Next, from the demand side, from the family side, it's getting split into 2 families. One family wants Mg and O. How many? 1 kg, 1 kg, 1 kg, right? One family. It is in the multiples of 1. Again, magnesium also in the multiples of 1 only. It's very easy for me to balance. Next, N and H3. So here, the other family, second family wants everything in the multiples of 3, 6, 9, 12, like that. And here, sodium is in the multiples of 1, 2. Done. Next come. Look, which one should I balance now? Mg is 3. The supply itself is 3 kgs at a time. How about here? The demand is 1 kg. So what we do? Supply 3 bags, 3 chelas. MgO. My supply of 3 kgs got demanded by one family which was 1 kg. So now I'm supplying 3 bags, so it is met. Supply and demand of magnesium is met. If that is the case, now next thing is oxygen. For that family, oxygen was 3 kgs, but the supply is only 1 kg. Now I have to balance here. Oxygen becomes 3 kgs. If that is the case, now go for hydrogen. Hydrogen becomes, if I say, hydrogen becomes 6 kgs, right? So if that is the case, what is the consumption here? It is in the multiples of 3, 6, 9. So give 2 packets of hydrogen and let us see. So if you are giving 2 packets of NH3, then there are 2 kgs of N which is required for the second family. Now, what is my supply? Yes, when I come to Mg3N2 in this big first chila, the supply is also 2 kgs. In one bag, at a time I am supplying 2 kgs and my demand also met. So, if I put these numbers, what are those numbers? Look here, writing these numbers is very important. So, where did I say the supply is 3 kgs? So, the demand made it to 3 kgs. This is my addition. Then oxygen has to get balanced. Oxygen demand, for that family, I am giving 3 kgs of oxygen, but I am supplying only 1 kg. For that, what I did is, I am adding 3 here. 3H2O. Please make it 3H2O. If that is the case, then 6 kg or 3 bags of hydrogen I am giving, or 6 kgs you take, because here it is 3. So, if I am giving 2 bags of NH3, it becomes 6 kgs and sodium is 2. Right? Okay. sodium, sorry, N, nitrogen. Okay, 2 kgs of nitrogen is what the other family, for the other family I'm giving, but then what am I supplying? Yes, it is also N2. So it's balanced. So the balanced equation is Mg3N2 plus 3H2O gives me MgO or 3MgO plus 2NH3. This is the balanced equation. You want me to write? So let me write it here. I hope you guys get my points, and this video is not a video just for showcasing. This video is for making you guys to understand more and more. So if you don't understand, we will discuss again in the class. But I'm sure by now you will understand. And this is also called your crisscross method. But here what are we speaking is in our general terms, because we are very much aware of rice, dal and supply of the food packets and demand like that. Then magnesium, nitrogen, oxygen, like this. So that is why we are going for visualization. Always the brain would like to see the things. It would like to visualize. Write down this equation. Of course, you don't need to write this in the brackets 3 and 2 and all. You don't need to write them in the brackets. All right. Now let me take some other equation. Let me go down and look for some other equation. Yeah, I'll go for the 18th one probably. I think I can stop there because too much of information may also disturb you. Okay. So here I get in 1 chila 1 kg and N and O3. Let us be intelligent here. NO3, nitrogen oxide, and supply and demand is also NO3. Why should we burden ourselves by splitting? No need. CO3, CO3. So keep it as it is. Let us take that itself as packets. So this NO3 is in the multiples of 1, 2, 3. It's in the multiples of 1 and this is also in the multiples of 2. Now let us go for H2CO3. H is in the multiples of 2, 4, 6 and CO3 as I said is in the multiples of 1, 2, 3. Okay. So let me come on the demand side. There is one family which wants K2CO3. In there, they are looking for K as 2 kgs. Okay, if that's the case, I have to increase my supply by 2 kgs. Okay, if I increase the supply of 2 potassium here, then even NO3 becomes 2, right? But look here, the demand is for 1 kg. So, for the second family wants 1 kg HNO3. So, what I should do? My supply is more, 2 kgs. So, I write it as 2HNO3. What are balanced now? Potassium is balanced, K is balanced, NO3 is also balanced. Now, the supply, the demand for the second family was only 1 kg, but we supplied 2 bags, 2 chelas. So, hydrogen became 2. But do we have 2 at a time supplied? Yes, it's supplied, done. And this is done. And how about CO3? It's multiples of 1 and here also it is looking out for the multiples of 1. Yes, it is solved at once. It's so easy to solve. Okay, now let me write down. I'll take a little place here and let me erase the board now and let me write down the balancing act. What we did? Supply and demand are met. Okay. Which one are we going to take? Where we see the ones where there is an imbalance. Should I work on K now? Potassium now? Yes, I need to work because the supply is 1 kg, demand is 2 kg. So, I have to increase the demand, the supply by 2 kgs. That is 2 packets, 2 KNO3. Done. Now, if I increase, again NO3 also came out to be 2 kgs and here again it is in requirement of 1 kg. So, supply 2 bags so that they will get 2 kgs. Now, H also increased by 1 kg. Now, what is the supply of H? For the second family, we are supplying 1 more kg extra or 2 bags, right? But here, how about the supply? Yes, 2 bags are there. So, no problem with CO, H2. Then CO3, there's only 1 kg that is being supplied, and of course it's getting consumed. Only 1 kg is getting consumed. So thereby there's no problem. And K2CO3, yes, it's a balanced equation now. Got it? Yes. Okay, fine. Let's move ahead and see if there are some more that I can solve. Let me go for this 29th, and rest of this, probably this is the time for me to leave you all with the rest of the equations, but I want everything to be solved. Okay. So again, the same thing. Now what we do? Here 2B and in the B2, see this is B2, BR6, comma 6, 6 BR. Okay. Another family, another Sheila has from the government itself 1 H and NO3 also 1. And this BR is in the multiples of 6, 12 as we increase the number of bags, 18. And B is the boron is in the multiples of 2, 4, 6. Now, let us see the requirements. So, one family requires, now I write down family 1, okay, requires BNO3 of 3. It means 1 kg of boron and NO3 in multiples of 3. 3, 6, 9 like that. And this is coming in 1, 2, 3. And another family, family 2, requires HBr, 1 hydrogen and Br also 1. That is multiples of 1, 2, 3. Here also multiples of 1, 2, 3. Done. Okay, let's balance the demand, supply and the demand. Okay, we look for, right, if you observe here, boron is supplied in 1 Chila, it is supplied with 2 kgs. How many are the demands? Only 1 kg. Now, where I should increase? Let me increase number of bags here to the first family. It became 2 now. If I do this thing, next, NO3 is this family, what I am talking, the family 1, it wants 3 kgs of NO3. So, I have to increase my supply by 3 HNO3. You can write it easily, 3 HNO3. Okay. So far, if I supply 3 bags of HNO3, it's got balance. And for the first family, I am giving 2 bags which contains boron and nitrogen oxide. In order to balance what is got supplied. Boron is got supplied by 2 kg. So that's why. Now, if I supply this, NO3 is how much? Yeah, 3 kgs. Yeah, so thereby I am increasing the supply of this HNO3 back to 3 kgs. And now hydrogen is 3. What do I do now? Hydrogen is 3. Therefore, here for the second family, I need to increase the supply by 3. So, I am supplying 3 packets at a time. Next, BR. Now, BR is when I am supplying BR 3 kgs and here BR is becoming 3. Oh, that's not possible. Then here at one time I am supplying 6 kg. So it has to be like multiples of, when it is multiples of 6, 12, 18. Even here this side also it has to go in the multiples of 6 at a time. 3 gone now. So 6. So when I say it is 6, hydrogen is also 6. At that time this has to go as 6. Got it? So let me write down. HNO3 has to be in the multiples of 3 didn't come. Now it has to be in the multiples of 6 which came. Okay, if that is the case, the boron which came was, the boron here was BNO3 of 3. At a time it is looking out for 3 kgs. But here when I supplied HNO3, now I am supplying 6 bags. So it means NO3 is also 6. Here the demand is NO3 3 kgs. Now if I am giving 2 kgs, then NO3 becomes 6 and what I am supplying is also 6 and it's met. And how about B, boron? Yes, it is 2 kgs I am supplying and here also the demand is 2 kgs. I am supplying 2 bags extra, so then it is done. Now the equation got balanced. Let me write it down for you what I have done. I'm erasing them. Okay. In case if you feel like I'm going a little fast or something, this is with respect to everyone's time. I'm going fast. What I do is let me delete and write down the equation now. What I said is B2 BR6. I'll keep it as it is. What we supplied here as was it not 6 HNO3? Yes. So that this become B2B and NO3 of 3 plus 6H and Br. That's balanced. So friends, I found this method to be very useful. So what we should do is we need to practice. So for that, I have lot many equations here for practicing. Once we practice, I guess we never get into a problem of balancing the chemical equations, and this should never be in our history. This should never be in our doubt list. That is what balancing the chemical equations. I'll be sharing this sheet with you all. Okay. What you can do, please go ahead and take the these equations and start balancing them one by one. And let's say from here on it goes. I've taken this from uh, internet, right? So what you do, you start balancing each and every equation here. So here comes from 8 standard chemical equations. We start for balancing. I've shown, I guess, around 4 to 5. Let me also pass this sheet to you guys so that you will have this in hand and you can start the balance. In case if I'm going fast, what you do? You pause the video, rewind back, get it back. Anyways, I will be passing this Word document so that it will be handy for you. Let us take this as a worksheet and start our work. Alright. Thank you.